Welcome to homework.
Okay, so for this problem, we have a resistor and an inductor connected, and we want to know at what rate is the battery transferring energy to the inductor at this particular time. T equals 1.61 tau L. Is that tau L? Yeah, tau inductor, tau L. Okay, so here we go. Let's do some derivatives. So we were trying to evaluate du dt at t equals 1.61 tau L. And then, so that means we need to evaluate the derivative of the energy of an inductor. So it's 1/2 L I squared. And then we can plug in our formula for the current in a charging inductor, which is this V over R times 1 minus e to the minus t over tau. So I'm just going to plug this in here. And then, oh yeah, we're given some other givens too. I'll write those down. But anyway, I'm going to plug in this I here and then evaluate du dt at t equals 1.6 tau L. And then before I do that, let me just go ahead and write down the other givens. So the EMF, I'll use voltage here. So it's 12.0. Oh, oops. 12.0 volts and R is 20 ohms. Do they actually give you the inductance? Oh no, but luckily you don't need it. Okay, because it's not really luck. Okay, so anyway, so let's go ahead and evaluate U as a function of I. So I can say that U is equal to 1/2 L times this whole thing squared. So then that's V squared over R squared. And then I'll just go ahead and expand it. So 1 minus 2 e to the minus t over tau L plus e to the minus 2 tau over t over tau. Okay, and let me get that other parenthesis. Okay, wonderful. And now let's differentiate. So du dt, so let's keep this 1/2 L v squared over R squared on the outside. And then we end up with, so this will get a 1 over tau factor. So you get and then taking the derivative of this negative will make this term positive. So I'm using the fact that tau equals L over R. I'm sure if you're working on problem on 93, that is like burned into your mind, but just in case. So yeah, here we go, 2t the minus t over tau L, and of course we know this ratio is 1.6 that we'll plug in a little bit. And this one term gets a negative, so that's minus 2, again, your R over L, your inverse factor of tau, e to the minus 2t over tau. Okay, and these 2's are going to cancel. Let's do some canceling in red. There we go, there we go. And this R cancels that R. Or both of these terms have to cancel this R. And then both of these terms have an L, which cancels this L. And we know we did the algebra right, or at least we have an indication that we did the algebra right, because we end up with something in units of power, V squared over R. That's the power in a resistor, except for we modify it with this exponential factor. Great. And then I just plugged in for V 12, R 20, and then tau L, T over tau L. I plugged in 1.61. And when I put that into a calculator, I got 1.15 watts.